For example 3, we are given that cosine of an angle S is equal to 2/3. And we know that angle S is between 3 pi over 2 and 2 pi. What quadrant is that? 3 pi over 2 and 2 pi is quadrant 4, yeah. So we know that the whole angle is in quadrant 4. We would like to use that information to find the cosine of S over 2, the sine of S over 2, and the tangent of S over 2. So let's just start at the beginning and let's try to find the cosine of half of S. So, cosine of half of S is always going to equal plus or minus the square root of 1 plus the cosine of whole S all over 2. That's just my formula, switching my A's to S's. Okay, I was given whole S plus or minus the square root of 1 plus 2/3 all over 2. So here's as far as I am right now, just substituting in what I know. I need to decide whether it's positive or negative. To do that, I have to think about what angle I'm trying to find. I'm trying to find the angle, the cosine of half of S. Well, if whole S was in 4th quadrant, where do you think half of it will be?
2nd.
Does that make sense to everyone? Are you sure? You don't know. You're just like agreeing. Where will it be? Does everybody believe it's in quadrant 2? It is in quadrant 2. Okay, here's how we know. If this is whole S, if I half all of that, if I half this, I'm at 3 pi over 4. If I half this, I'm at half of S. If I half this, I'm at pi. So we know it's going to be between 3 pi over 4 and pi, which is in quadrant 2, right? So is the cosine positive or negative? If
Negative.
half of the angle is in quadrant 2, it's negative. So we know it's negative, square root of. And we need to simplify that complex fraction. So we're going to multiply through by 3. So we're going to multiply by 3 on top and 3 on bottom. In other words, we're going to multiply 3 to all of them. So that gives us 3 plus 2, which is what?
6.
All over 6. Make sense so far? Now what's wrong? We have to split the fraction apart and get the square root out of the denominator, right? Okay, so that equals negative square root of 5 over the square root of 6. And that has to be rationalized up to the negative square root of 30 over 6. Square root of 30 won't simplify. So we're finished with cosine. That is cosine of half of S. For the second part, we are asked to find the sine of half of S. It's very similar to finding the cosine. It's plus or minus, and the only difference is instead of 1 plus the cosine of whole S, it's 1 minus the cosine of whole S. All over 2. We're still in quadrant 2, but in quadrant 2, sine is positive. So really we have positive square root of 1 minus the cosine of whole S, which is 2/3, all over 2. So we'll perform the same operation here. We'll multiply top and bottom through by 3 to simplify the complex fraction. And we will get 3 minus 2 over 6, right? So square root of 1/6, which we will split up into the square root of 1 over the square root of 6, which is really 1 over the square root of 6, right? Right. Which is square root of 6 over 6. Good. And now we can find the tangent. The tangent of half of an angle. Couldn't I just say, is this sine divided by this cosine?
Mm-hmm.
I really could, right? Yes? But you know why I'm not going to? Because if that were the only thing I asked you to do, would you take the time to go find sine of half S and cosine of half S and then divide them? No. So we're going to work it as if we're starting from scratch. So if this were the only problem I had, and I was only giving cosine, I would probably use the identity tangent of half S is equal to plus or minus the square root of 1 minus cosine of whole S divided by 1 plus cosine of whole S. And because it's tangent and because it's in quadrant 2, I know that tangent is negative square root of 1 minus 2/3 over 1 plus 2/3. You should be getting really good at simplifying complex fractions by now. We multiply through by 3 over 3, and we get 3 minus 2, which is 1, over 3 plus 2, which is 5. Do I need to back up and show you guys where that came from? You're okay? Yes? Alright. Split it apart, and we have negative square root of 1 over the square root of 5, which simplifies to negative square root of 5 over 5. And there is the tangent of half of s. So for example 4, if you notice a little bit different instructions, it says simplify each expression. We're not actually looking for a value, so they're not going to have number answers. Basically what we're doing here is pattern recognition. You should notice that part A, plus or minus the square root of 1 plus cosine of 12x over 2, looks a lot like the cosine of half an angle, right? The cosine of A over 2. Well, if this is A, right, what's A over 2?
No, it's 12 over 2.
It's 12x over 2, which is 6x. So that's what we're looking for here. For you to simplify it down. It will still have x's in it. Now make sure that that makes sense. Cosine of this angle equals plus or minus 1 plus cosine of double that angle over 2. And it does. This is the left side. That's half. And this is the right side. And that's your whole angle. Do you guys see that pattern? Okay, let's look at the next one. 1 minus the cosine of 5 alpha divided by sine of 5 alpha looks like the third tangent half angle identity. So that's going to equal tangent of half of whatever that angle is. Why am I using s's? All right, if this is capital A, then what does this equal? Tangent of... This should be the half. This should be the half. This should be the whole. Yeah, so be careful. Make sure you don't get them backwards.
5 alpha over 2.
So 5 alpha over 2 or 2.5 alpha. Let's see if that makes sense. We take tangent of 5 alpha over 2, and it has to equal 1 minus cosine of 5 alpha over sine of 5 alpha. That's our formula basically. So is that true? Are those two things equal? Yeah, we just pretend the alpha is like a capital A, right? And then they make sense? Yeah? Okay. We have one more. Guess what it is?
Verifying.
It's a verifying. I know you want to see another.
I wanted to assume them slides.
You wanted a note, didn't you?
Yes.
Yeah, a caution. Well, it's not. It's a verifying. I feel like you guys probably still need practice with verifying. So for this problem, we would like to verify that the quantity sine of half x plus cosine of half x squared is equal to 1 plus sine x. For this problem, we're going to start on the left side, and I think we should just distribute it out. So we can square, double square it, or FOIL it. So if we square, double square it, we have sine squared of x over 2 plus 2 times sine of x over 2 cosine of x over 2 plus cosine squared of x over 2. So take a minute and make sure you understand how I FOILed that. If you don't square, double square well, just go off to the side, write it twice, and FOIL it out. So we have sine squared of x over 2 plus 2 times sine of x over 2 times cosine of x over 2 plus cosine squared of x over 2. Any questions up to this point? What's sine squared plus cosine squared no matter what the angles are? 1. As long as, remember, as long as the angles are the same. So since these are both x over 2's, sine squared plus cosine squared has to equal 1. So here's where we are. 1 plus 2 sine of half x cosine of half x. Which is good because we're starting to look like what we want. We have the 1 here and the 1 here, the plus sign and the plus sign. If you can convince me that 2 sine of half x cosine of half x equals sine of whole x, I'll believe it.
Isn't that the same as a double angle identity?
Yeah, could you read it to me? We know that sine of,
2a is
so in this case, sine of 2a equals 2 times, help, sine of a cosine of a. Okay, so, let's try again. Okay, so in this case, which one, I think this is the right side. Is that what y'all think? Okay, so in this case, a is x over 2. Okay, so what does that mean sine of 2a is? Sine of 2 times x over 2 is sine of x. I believe that, don't you? Okay, so using a double angle identity, which is weird because it looks like a half angle, but it turns out to be a double angle. Yeah, so it's weird because the doubles and halves can go back and forth between each other. So you have to kind of like be real careful with those. So it's really 1 plus sine of x. Believe it or not, if you didn't see that, you could still get the same answer by multiplying these pieces in using the identities. I'm going to show you really quick, but you don't have to do it that way. But I just thought it would be nice to show you. If you didn't see that, you could now substitute sine of half x is plus or minus the square root of 1 minus cosine of whole x over, hey guys, 1 minus cosine of whole x over 2, and cosine of half x is plus or minus the square root of 1 plus the cosine of x all over 2. Okay. So we have 1 plus 2 times. If I multiply a positive by a positive, I get a. If I multiply a negative by a negative, I get a positive. A negative by a negative, I get a positive. So do you see that the pluses and minuses cancel each other out here? And then I have the square root times the square root, which is the square root of 1 minus cosine squared. If I FOIL those tops out, I get 1 minus cosine squared over 2 times 2, which is 4. Well, guys, what is 1 minus cosine squared? Sine squared. So really I have 1 plus 2 times the square root of sine squared over 4, which is 1 plus 2 sine x over 2. And what happens to those 2's? They cancel. So it could be worked out if you didn't see that connection to the double angles. If you worked it like a half angle, it would just take a little time.
That was easier to me than the double angle.
Well, good. Then you have 2 ways to do it. That wraps up section 5.6 if you don't have any other questions. But now remember, individually the sections are okay. But when you go back and you're looking through homework, remember that you're going to have to be able to do them on the test, 5.3, 5.4, 5.5, 5.6, all mixed up. We will have one more section before we end this unit. It will be 6.1. And for some reason, it just got stuck in this unit. But it's an easy section. So we'll cover it next time.